Okay, we are back. This is Statistics 189. I am Mr. Pileggi, and let's jump in. 1.3, we're on 1.3, Chapter 1. Again, very heavy in the terminology, Chapter 1, so I won't be demonstrating a lot of stuff on the board here. Just try to flesh some of this reading out for you. So, data collection and sampling techniques, 1.3. So how can I collect data? Well, telephone surveys are very popular because it's not that expensive, and lots of people in our country have phones. So have an advantage over personal interview surveys, and they are less costly. So yeah, they're cheaper. People may be more candid on the phone if you can get them to stay on the phone. And so, you know, there's also going to be a lot of hang-ups. So that can be kind of difficult to get a simple random sample if a good part of your population doesn't commit to answering questions on the phone. Okay, so the problem with that is you will miss, there are people that don't have phones or don't use phones or have unlisted numbers, or, you know, and so don't have the time to talk to you if they hang up. And so that's, you got to be careful with phone surveys because they can be inaccurate sometimes. All right, so let's go with mailed questionnaire surveys. Can be used to cover a wider geographic area than telephone surveys or personal interviews, since mailed questionnaire surveys are less expensive to conduct. Also, respondents can remain anonymous if they desire. The disadvantages of mailed questionnaire surveys include a low number of responses. So again, a lot of people just throw it away with the junk mail. And so, and sometimes difficult reading handwriting if they're actually writing out comments. Personal interview surveys have the advantage of obtaining in-depth responses to questions, meaning if somebody doesn't understand the question, they can ask you to explain it, or you could ask a follow-up question if they answer in a certain way. But the disadvantages, those are costly. It's expensive to get people in a room to answer questions. Data can be collected in other ways, such as surveying records or direct observation of situations. Sure. And so there's a lot of different ways. Obviously nowadays too, with the computer, you can do surveys on the computer. Again, there's going to be some response bias there if it's not randomly sampled or if it isn't a specific population you're looking at. So, all right, so let's look at random sampling. That is extremely important in statistics, is to have a simple random sample. That is a sample in which all members of a population have an equal chance of being picked. And so to get a truly random sample can be kind of tough. You know, if I say my population is part-time students at MATC, that's already a really, really big number. And so each one of those have to be assigned a number, and then I either use a random number generator or a table, and I randomly choose out of that sample, and that gives you a good picture of the population. Unfortunately, a lot of places do convenience samples where they just give a survey to people in the English department and say, here, give these to your students. Well, not every part-time student at MATC will be taking an English class, you know, and so that's called a convenience sample and not a random sample. We need randomness to make generalizations about the population. There has to be an equal chance of picking anybody, that's in your population. So then they talk about table D. That's on page 11. I copied off a little piece of it for you. It's also in your book. In the e-book, you can find it. There's a whole page of random numbers. All right, there's a systematic sampling. Is a sample obtained by selecting every K member of a population when K is a counting number. So that would be like if I had a class of 24 students and I wanted 6 groups, I'd say, okay, count off by 4s. Just 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And then that's how we determine groups. That's called a systematic sampling. And so that you could do with, you're choosing like alphabetically, if everybody is alphabetically, and I say, I will just go every 100th student, until I have blank. But again, then you might not get through the whole alphabet, and so you're leaving people out based on the first letter of their last name. Systematic sampling, you must be careful about how the subjects in the population are numbered. If subjects were arranged in a manner such as wife, husband, every 40th subject were selected, the sample would consist of all husbands. Because that would be, so yeah, you've got to be careful with systematic sampling. Stratified sample, a stratified random sample we see. That's when you, a stratified sample is a sample obtained by dividing the population into subgroups or strata according to some characteristic relevant to the study. So there can be several subgroups. There could be 10 subgroups or 2 subgroups. Samples within the strata would be randomly selected then. For example, suppose the president of a 2-year college wants to learn how students feel about a certain issue. Furthermore, the president wishes to see if the opinions of first-year students differ from that of second-year students. So the president will randomly select students from each subgroup to use as the sample and then compare the results and see if they're the same. You'll see stratified random samples on products. A lot of times you buy a product of some form, and if it's like a refrigerator or something, they'll say, what's your household income? And there's 4 different subgroups like that. And you fill in one of them and then answer the rest of the survey. Well, they just put you in a strata. Now, if you identify your household income, they know who's buying their product, and that helps them to advertise to that group, the group that most, liked it or didn't like it. Cluster sampling. Cluster sampling is just, that might be like just proximity. So I might say all the hospitals in Milwaukee County. Well, that would be a cluster. It is based on a county, but they're all going to be contained in the same part of Wisconsin. If I say all the hospitals in Dodge County, that would be a cluster. So clusters are selected by usually where they are into clusters and selecting at random. So within the cluster, we could randomly select. All right. And then they have some examples on page 12 here of random choice. All the cars got a number, use the table, and then you end up with those cars. Systematic, they just chose every 3rd bottle of soda to look to make sure it was filled correctly. Stratified random sample, looks like there's men and women, and then the actual chosen, randomly chose men, randomly chose women, and there's your group. And then cluster, see how they're in that area and that area. So you just chose by area. Okay, so that's page 12. Other sampling methods, a convenience sample, that's bad. That's usually, your data doesn't transfer well. Like using a class of students instead of a random sample. So teachers make mistakes like that sometimes. When I taught at the public school that I taught at, there was a teacher that stood up and said, my German 4 students all study 20 hours a week, and I asked them, and I didn't know students really work that hard, and so you guys got to go a little easier on these people. And it's like, okay, that doesn't transfer to the rest of the school. That was a convenience sample of people that stuck with a language for 4 years, and so that wasn't a typical or good or accurate sample. That would be a convenience sample. It was convenient because they were all in her class and she gave them a survey, but it couldn't be, then we couldn't make any generalizations about the population of our students based on that sample. If you had, like in restaurants, they used to have cards. I hope they still don't, but like cards, like how did we do cards that you'd fill out. Like I know Pizza Hut used to have them. That's a bad way of collecting data because you only get the extremes there. People that are very dissatisfied will fill those out, and more often dissatisfied, or people that just thought, their waitress was just, or waiter was just over the moon and just everything was great. They'll fill it out, but you don't really get, unless you make everybody do it, you get what's called a volunteer sample of self-selected sample. That's it's called response bias is what that's actually called, because the respondents feel strongly one way or another about things. That's why you got to be careful with these polls, like opinion polls. A lot of times, if you're ESPN will do that, where they'll run opinion polls about what do you think about this athlete or whatever. Well, that's only people that are into sports enough to watch ESPN think that about the athletes. And so that Consumer Reports will do that. They'll poll their readers. Well, that's a very specific part of the population that has a subscription to Consumer Reports. And so that isn't necessarily going to be, it's kind of a non-scientific poll, because the response bias can really change the outcome of the experiment. So then sampling error, that would be like the phone thing. If you were worried about homeless populations, and you wanted to talk to homeless people, and you did a phone survey, you probably aren't going to get a lot of homeless people with phones, and so that wouldn't be a priority for most that don't have a roof over their head, and so you wouldn't get much decent information there. A non-sampling error occurs when data is non-representative, and so if you specifically cut somebody out of participating, that's a non-sampling error. And then data could be collected by using a defective scale or surveys. Surveys can sometimes be misleading, how they're written and presented, and so you've got to be careful about that. Defective collection could also be there was like a problem with let's say I was weighing meat that people bought on the way out of the door, but then at the store, but we found out that our scale was inaccurate. Then I wouldn't have any usable data. All right, so let's look at page 14 here. Out of 10 hospitals in a municipality, a researcher selects one and collects records for a 24-hour period and the type of emergencies that that were treated. That would be a cluster. That's a cluster sample because there's 10 hospitals in a municipality, so they're all next to each other, and he chose one. Let's see, a researcher divides a group of students according to gender, major field, low, average, and high grade point average, and then randomly selects 6 students from each group to answer questions in a survey. That would be definitely stratified because you put all of these different, stipulations down and got them, and then took random samples out of those. The subscribers to a magazine are numbered. Then a sample of these people is selected using random numbers. So that is a random sample, but again, that might suffer from the errors that we talked about, like a sampling error. Because you're only asking, I mean, if your population is just the people that read your magazine, then that's fine. But they didn't tell us what they were going to be asking there. And then every 10th bottle of energized soda is selected to make sure it's filled right. That's systematic. It's systematically choosing your sample. American culture and drug use. What type of survey did they use? Oh, I didn't put down the answers for this one. Okay, well, good. Then we're doing this together here. Let's do bottom of the page 14, 1.3. Assume you're a member of a research team and have become increasingly concerned about drugs used by professional sports players as one of several factors affecting people's attitudes towards drug use in general. You set up a plan and conduct a survey on how people believe the American culture, television, movies, magazines, and popular music influences illegal drug use. Your survey consists of 2,250 adults and adolescents from around the country. A consumer group petitions you for more information about your survey. Answer the following questions about the survey. Okay, research team have become increasingly concerned. All right, and drug use in general. You set up a plan and conduct a survey on how people believe the Americans. So let's see. What type of survey did you use? I don't think it says, does it? It says phone, mail, or interview. Your survey consists. What type of scores did you use and why? What are the advantages and disadvantages of surveying methods you did not use? Did you use a random method for deciding who would be in your sample? Which of the methods, stratified, systematic, cluster, volunteer, or convenience, did you use? Why was the method more appropriate for this type of data collection? And if a convenience sample were obtained consisting of only adolescents, how would the results of the study be affected? Well, then you could only make generalizations about adolescents. So they didn't give us any of that information. I guess they wanted you to kind of make up your own plan for that one. And so if you were running it, like, what would you do? And see, that phone, mail, or interview, there's pluses and minuses to all of those. But interviewing, you might not get honest answers because people figure, even if they don't give you their name, and you're saying it's anonymous up and down, you're still talking to another person. And so you might not answer truthfully on those. And so phone and mail, you might get a lot of non-response, like hang-ups and just throw it away. So you might have to send out a lot more. And so, yeah, that's tough. The also thing with phone and mail is you might not get the respondents that you want. You know, the mail, if you want adolescents and you're trying to mail it to them, it has to go through their parents. And who knows if they filled it out or if the parents filled it out. So that's the problem with, there's a lot of problems with data collection. All right, let's look at one for experimental design. So observational settings, that is when you don't run an experiment. You don't, you just look at something that happened. So observational study would be if you found people that have been smoking since they were 14 years old and now they're 30. You could do an observational study on the effects of smoking on these people. But it wouldn't be an experiment. An experiment would mean you grabbed 100 people and 50 of them you made start smoking a pack a day when they were 14, and the other ones didn't get to smoke ever, and that would not be okay to do. There's ethical problems with running experiments like that. And so observational studies, there are main types of observational studies. One time the study is called a cross-sectional study, when the data collected using records obtained from past. The study is called a retrospective study. And if they look at the past and the present, it's called a longitudinal study. That's a big word. All right, but the things what's good about observational is it's in a natural setting. What's bad about observational, there can be confounding variables, meaning if I started smoking when I was 14 years old and I kept smoking until I was 30, I might have also engaged in other unhealthy activities other than just smoking. And so, what else could have caused, problems, heart disease? If I'm also 100 pounds overweight and a heavy smoker, the weight could be what is giving me heart problems if that's what's being tested. And so there's confounding variables that can be, that's the problem with observational studies. Natural setting is good in that you won't change things. Observational studies have disadvantages to, as mentioned previously, since the variables are not controlled, cause and effect can be hard to establish. All right. Experimental studies, the researcher manipulates one of the variables and tries to determine how the manipulation influences the other variables. And so sometimes experimental studies that are poorly set up can also be kind of misleading. So you got to watch out. So true experimental study, the subjects should be assigned to groups randomly. Also, the treatments should be assigned to groups at random. That's important. So sometimes when random assignment is not possible, researchers use intact groups. These type of studies are done quite often in education, where I told you might be just using who's in your class. In the form of existing classrooms, when these groups are used, the study is said to be quasi-experimental, meaning if you didn't use a simple random sample, it's really hard to generalize to the population. And so it gets a quasi-experimental to it. Independent variable in an experimental study is the one that's being manipulated, and then the dependent variable is kind of the outcome. So we have the explanatory variable and the outcome variable. So that would be like if they made a new medication to help with retinal degeneration. You would give, let's say you had 1,000 participants, all of them had retinal degeneration, and 500 of them would get the actual pill, and 500, that's called the control group, would get a fake pill. It would do nothing. It's a sugar pill or something. And it should be done double blind, meaning that the people giving the pills don't know who's control and who's experimental, and the experimental people don't know. They should know. It's ethical to tell them, look, half of you are getting the real thing, half of you aren't. But there's just a lot of psychology behind how our body works, where if somebody who you perceive as smart, that wears glasses and a lab coat, gives you something and says this will fix you, a lot of times your brain will trick you into thinking you're fixed, thinking that you can. Now, with something like that, they're going to do eye tests and see if you can pass those eye tests or not, and be able to, look at what's going on. But that's why you use a treatment group and a control group to try to limit the effect of you knowing. A lot of times you're testing headache medication. Lots of people suffer from headache and pain, and there's something called the Hawthorne effect, where, like I said, you perceive somebody smart gave you this pill and they said it would cure your headaches, and voila, your headaches are cured. Now, a lot of people go, so they were faking it the whole time. No. They just believed. It's called the placebo effect. They believed that it would fix them, and their body sent the signals it was fixed. And so if you know there's a 50-50 chance that you're going to be getting a fake pill, it's less likely that the Hawthorne effect is going to kick in, or the placebo effect is going to be there. So confounding variable is another cause that influences the dependent or outcome variable. And so you've got to be careful there with a lot of times with observational studies. That was, I think, when polio was striking down children in our country, researchers thought it was dairy, like ice cream, for a little bit, because there was a high correlation between ice cream consumption and polio cases. And it turned out it was heat was actually bringing it to the surface. So it was not ice cream. So, so you got to watch out for confounding variables. Are variables that were lurking somewhere that you didn't think of, and it can affect what's going on. So the placebo effect, yeah, I talked about that already. Random design, you want to make sure it's random. General guidelines for procedures on page 18 would be: formulate the purpose of the study, identify the variables for the study, define the population, decide what sampling method you'll use to collect the data, summarize the data, and perform any statistical calculations needed, and interpret the results. And then the last couple of pages here, experimental design. We talk about that. And the answers are already on there for this one. So what is the independent variable? Was the type of essay. English teacher assigned a certain essay where they had to reflect on their lives. So it was an experiment because she assigned, some students this and some students that, a different thing. What is the dependent variable? The score of their life outlook questionnaire. So she assigned two different kinds of essay, one that was highly reflective and one that wasn't. And then they had them take the score on the life outcome questionnaire. What would be a confounding variable? There's a lot of stuff there. Age, upbringing, income, can all affect results. Random assignment of subjects is helpful, but it's likely she didn't randomly assign this across everybody in the school, but rather just to her class. So that's already a very specific setting. In this study, the sample of 30 participants was used total. That was the sample size. Not huge, but that also coincides with like a class. Do you agree with the conclusion? I said no. With a small and likely convenient sample and so many other confounding variables, conclusions are kind of suspect in this case. Yeah. So uses and misuses of statistics. Watch out. Statistics don't lie, but liars use statistics. You know, nowadays they call it spin. They call it, sometimes people just make stuff up and say there was a study done. So make sure to check sources, especially if it's just hanging out there on the internet. There's a lot of wild and crazy stuff out there. So, but if it is founded in statistics, you still have to be careful. Who did the study? Why did they do the study? When did they do the study? How big was it? You know, good experimental scientists will report all of this out, and you'll be able to, you know, usually link and see when they actually did the study. And so, you know, it's not baloney. So suspect samples, that can be at play. A lot of times if it's in advertising, be very, very, very attuned to the fact that they might have chosen specific things to check. And so when results are interpreted from using small samples, convenient samples, volunteer samples, care should be used in generalizing the results to the entire population. And ambiguous averages, changing the subject, detached statistics, implied connections, misleading graphs, watch out for those, and faulty survey questions. Like misleading survey questions can happen. And so like today's cigarettes, the vapor or electronic cigarettes have increased dramatically over the past 5 years. Compared to traditional tobacco products, a lot of research has not been performed on alternative smoking devices, even though the sales of these devices have doubled and then tripled. So one study conducted at Virginia Commonwealth University considered the following factors: carbon monoxide concentration, heart rate, subjective effects on the user, and plasma nicotine concentration. The study consisted of 32 subjects. The subjects came from 4 separate groups: traditional cigarettes, 18 milligram nicotine cartridge vapor brand, 16 milligram nicotine cartridge vapor brand, and a device containing no vapor. So that would have been their control group. After 5 minutes of smoking, the smoker of the traditional cigarette saw increased levels of carbon monoxide, heart rate, and plasma nicotine. The electronic vapor cigarette smokers did not see a significant increase in heart rate or subjective effects to the user. Answer the following. What types of study was this? It was an experiment because they imposed a treatment. What was the independent and dependent variable? Independent was the smoking device. Dependent, they measured your carbon monoxide, your heart rate, and your plasma nicotine. Which was the treatment group? The treatment group contained the no vapors. Could the subject, well, and that's also called like the control group instead of the treatment group, contain no vapors. Could the subject blood pressure be affected by knowing that they're part of the study? If knowledge affected the blood pressure, it would have likely done it in both groups. So, you know, even the ones that were just huff and vapor, basically. List some of the possible confounding variables. Age, gender, physical fitness. Did you smoke before? You know, if you already have kind of a nicotine tolerance, that could change the outcome of an experiment like this. Do you think this is a good way to study the effect of smokeless tobacco? The design was okay, but the generalizations will only be good for the subjects with the same backgrounds. So you'd have to maybe expand on this and see what's going on. So, all right. So that is it for chapter 1. Again, in the future, chapter 2, chapter 3, I'm going to be doing the whiteboard a lot more. I'm going to be writing on it and stuff. So this was just basically terminology. All right. Thank you.